All right, so today we're going to be going over project 3, which is combined Couette Poiseuille flow. So right now we're starting off in Workbench. We're gonna go on here to Fluid Flow Fluent, and we want to drag that here. Okay, so now that we're here, we just want to right-click Geometry, and we want to go to New Design Modeler, Geometry, and we're gonna wait till that boots up. Okay, so now that we're here, I'm gonna change to the XY plane and click on the Z, so we're set right here. And now we want to click on New Sketch right here. So we're gonna have Sketch 1, going to move over to Sketching, and we're gonna click on Rectangle. Right here, we're gonna make a rectangular shape. We're gonna alter it in a second. So now we go to dimensions, and we're gonna alter the dimensions to what we were required. So height 1, I'm gonna have it as 1.5 meters. So it's gonna be nice and short. And then here to fix the height, other one was the length. The height is going to be 0.01 meters, and it's going to be really small right here. Yeah. Okay, so now that we have this, we're going to go to concept, and we're going to go from surface sketches, and we're going to click on our sketch 1, apply, and then up here generate. So now that we have this, we're done with our geometry part. So we're going to exit out of here, and we're going to click on mesh. I'm gonna wait till that opens up. Okay, so now we're here. Click on the z-axis again, and we're just gonna do this to move around easier. Okay, so now that we're here, we're gonna where is this? We're gonna go to edge select, and right here we're gonna click on this, and we want to click on the N key. So now we're gonna start naming these. So the one on the leftmost side is gonna be the inlet. The one on the top, and we could open these up to double check that we're actually doing something. So we're gonna have uh, a top moving wall, and we also are gonna have in this example for the combined flow, we have the top and the uh, bottom walls moving. So we're gonna call this the bottom moving wall, just so we have this in check. And then at the end right here, let me just go right here. Okay, so we're gonna click N again, and then this one is gonna be the outlet. And then for body select, we're just gonna click on the whole thing, and we're gonna name this the fluid. All right. So now that we have this part done, we're going to go to this mesh on the left side, and we want to go to our element size. So the element size, we're just going to set this to 5 to the e, or 5e to the -4th. So we're going to press on that, and we're going to enter, and then we want to generate. This part takes a bit of time. You could skip ahead. Last time it took a couple minutes, so yeah. All right, so it took a minute, a couple, but now we have the mesh right here, and now that we're finished with the mesh, we want to exit, and right here, we're gonna right click, and we're gonna update until we get the check mark, and now we go on to the next step, which is setup. Okay, so now we wanna click double position. We're gonna use 4 processes for this. You could also use 16. Just like to use 4. Okay. Okay, so now we want to go right here to the side, and we want to find the models drop down. Gonna go to viscous, double tap, double click that, and we want to change that to laminar. We click OK. Yeah, so it's gonna be changed to laminar, and now we want to find the boundary condition drop down. So right here, we're gonna be changing the speeds. So we double click to access them. So we leave this alone, and the velocity magnitude for the inlet is just going to be 5 meters per second, and we want to apply. We're gonna do that again just in case. Flow, interior fluid, we don't need to touch that. The outlet, so the outlet, we don't really know the velocity that we're dealing with. So all we're gonna have to do here is just we're gonna prevent reversal flow so it doesn't mess up the the readings. Let me see if it did. Okay, yeah. Okay, so and then for the walls, we have the bottom moving wall and the top moving wall. We're gonna go to the bottom moving wall first. Okay, so this is the bottom moving wall. We're gonna set it as a moving wall, and the speed, so this is just magnitude. The bottom moving wall is gonna be moving at -2 meters per second, so that's 2 meters per second to the left, so we just wanna change the direction to -1. We're going to apply, we have no slope condition right here. And for top moving wall, hmm, um, we're gonna do the same thing. Uh, Just leave it like that, and it's gonna be 3 meters per second to the right. So the direction we're just gonna leave as that. Okay. So now that we have these right here, just gonna double check this one more time. We have that. We have this. Okay, perfect. So now that we have this, we're going to go to materials, and we're going to go to the drop down for fluid and air. It's going to open this panel. The constant, the density we want to leave the same. The viscosity we're going to change to 6e to the -5. I'm going to create that again. All right, perfect. So now we go over to right here, the reference values. So this is where we double check this is going to be the inlet velocity. So right here it appears as, it appears as, uh, 1 meter per second. We're going to want to change that to, what was it, 5 meters per second. All right, so now that we've done that, we could double check see if the methods look fine. Okay, so yeah, the default settings are fine, and oh, not here. We are going to move on to the monitors and the residuals. So for the residuals, we're going to set all of these to 1e to the -6. And we're just going to set that like that. So we'll check that. We got all of them, and okay, so now that we're done with this, we're going to double click initialization, go to more settings. For the number of iterations, we're just going to change this, make it a little bit higher, 25. And we're going to apply right here. And now that we're done here, we're going to click initialize. So it's going to go through the 25 iterations. Wait till it's done. And we're going to give it a second. Okay, so right here, we wait until it says done. And now we could continue on to run calculations. And right here, we're just going to set the number of parameters to 500. Sometimes it makes you wait. But if not, we're just gonna go all the way down, and we're gonna click calculate. This is also gonna take a second, so feel free to skip this part. The software should tell you when the iterations are done. There we go. All right. So now we get the pop-up. We have finished the calculation. So we're just gonna minimize this and we can move on to the final part, which is the results. So uh, the the contour, we're gonna do the first one is the velocity. Contour, we're going to do this along symmetry 1. We're gonna change the velocity to the variable to velocity, and we're going to change the number of contours over to 200. Loading up. Ooh. All right, so that's how that should look. We're going to deselect it and make a new contour. We're going to call this the pressure contour, and as expected, well, we're going to change it to symmetry 1 again, pressure global, and then to 200 to match the other one. Okay, that looks good. Okay, so now we're going to make the general velocity vector. We're going to click on the vector icon at the top to make the velocity vector, and we're going to make the location symmetry 1. We're going to leave all of these the same. And you're going to apply. And since we have like a lot of big arrows, we're just going to go to symbols. We're going to go to 3D arrow, and we're going to change this to 0.05. Makes it nicer to look at. There we go. So there we have that. I'm just going to zoom into the middle here for a sec. So we're going to deselect, and we're going to go to location, and we're going to make a line. So we're analyzing the midpoint and the outlet line for this project. So I'm just going to name this midpoint line. So the midpoint line, it's going to start at 0.75 and the x coordinate for both. So it's going to be a vertical line. And the second value is going to be 0.01, which is the height. The rest is going to be the same. The samples is just going to be 100 to get a good reading. Okay, so here, this yellow lines, that, and then we're going to move over to the outlet. So I'm going to make another line, and we're going to name this outlet line. The outlet line, some people set it to 1.49, 1.499. I just found that 1.5 looks better for me. The height for the second one is also going to be 0.1 and 100. So we apply that. We're going to find right here. And lastly, I'm just going to make a last one for now. And I'm going to call this max height line. It's kind of where the peak is. We're going to use it to find the max velocity later. So this one is going to be 0 to 1.5, and the height, we're just going to leave it at 0 for now. Change the samples to 100. We should just see this as a line going down. Yeah, that's fine. We're going to change this later on. We're just going to leave this as that because we don't know where the max height is going to be. Okay, so now that we made these 3 lines at the midpoint and the outlet and the bottom for now, we want to make a new vector for, we're going to call this midpoint velocity, and we want to move it to the midpoint line, and larger factor, and the velocity, yeah, we should just leave it to that. The symbol, we're just going to change it to 3, D arrow, and 0.05, apply. So now if we zoom into this part, we are going to see that since the bottom plate had negative velocity, where it's a bit negative on the bottom, and top plate positive velocity has more positive. It doesn't start at the 0 point, and we're gonna want to find where this maximum part is. But before we do that, we are also gonna go to the end, and we're going to make a new vector and call it outlet velocity, since we're comparing these two in a bit. And we're going to change the location to the outlet line, and 3D arrow once again to 0.05, and same thing there. So now that we have that done, I'm just going to zoom into the outlet for now, and I'm going to make a point. This point I'm going to call max v height. So max v height, max v point. So the method, we're just gonna our maximum, and we're gonna put it along the outlet line, and the variable is gonna be the u velocity, and we're also gonna go to the symbol. We're just gonna make this a ball, and the size, we're gonna make it 0.005, so a little bit smaller, and we're going to apply. And as you see, the maximum velocity is gonna be around here. So this is the apex, which is going to come in useful a bit later. All right, so now that we have this, we're going to go up here. We're going to create a table. This table, I just call it max velocity and height. So this column is going to be max v, and this column is going to be height. So we're going to start off with the height first. So for the height, we want to go to function CFD and probe, and inside the parentheses, we want to the variable and use y, and then the point at, we're going to go to max v height. Yeah, max v height. So as we can see here, the max height is at 5.960 e negative 0.3 meters. So we're going to go back to the viewer right now, and we're going to go to the max height line. And now that we know this height, we're just going to set the y coordinates equal to this. So 5.960 e negative 0.3, and just copy that. Okay, so now we have this line at this height, which is good. And now we can go back to the table viewer. Oh, I don't know if I messed that up. but it's fine. Okay, yeah, okay, we're back. So now that we have this, we're going to look at the max v, and we're going to go to back to functions and CFD post. There should be a max val, and inside the parentheses, we're going to want to go to variable velocity u, which is what we were looking at before, and at. So max value, we're going to do along the max height line. And once we get that, this is what we're going to get, 7.433 meters per second. Okay, so that's good. We're getting close to the end. All we need to do is look at the chart for the midpoint and the outlet. So we're going to go up here. We're going to create a chart. This chart is going to be midpoint versus outlet velocity vectors. And click OK. We're going to get a pop-up like this. And so the title, we're just going to call this midpoint versus outlet velocity vectors. You don't have to name it. I'm just naming it. We're going to leave it as XY line, data series, series 1. So the first series, we're going to call it the midpoint. And the location, we're going to set it to the midpoint. And for the x-axis, we want to set the velocity, the variable to velocity u, and for y-axis, we want to set the variable to y. And yeah, that's all we got to change. And we're going to apply. Should get a nice curve. There we go. All right. So now back to data series. We click on this right here to create a new series. We're going to change this series to outlet. And we're going to put the line on the outlet. We're going to apply. All the other stuff stays the same. All right. So as you can see in this example, the max velocity is not at the outlet, which can be a misconception. And as you can see, like the midpoint velocity is higher than the outlet velocity, but the midpoint velocity is not the maximum velocity. That's why we made the horizontal to try to find the maximum along this line, since it's going to be the apex and throughout the whole pipe per se. And that should be it for the project. Here we have the the chart. All that's left is to look at the pressure gradient, but in the instructions, it says to use theories, so I'm guessing you just calculate it by hand. There should also be a way to do it here, but you can't really show your steps, I guess. So that's just going to be done by hand, or using some sort of other steps. Okay, so here we have the chart. Here we have the table, max velocity, and at the height it happens using our results. Here is the velocity vectors for the outlet, velocity vectors for the midpoint. And then, well, we could go back to look at the pressure contours, the velocity contours for the boundary layers, and that will be the project.